Have you ever done an egg drop experiment at school? You know, where you build a special container to protect an egg from a fall. You might drop it from a ladder, or maybe even the roof of your school building. It is a super fun way to learn about physics. But what if we took this experiment to the next level? I mean, a way bigger level. Let's think about dropping an egg from space. It sounds like something out of a science fiction movie, doesn't it? But thinking about it helps us understand some really big ideas about our planet and the forces that shape everything around us. It's a fantastic thought experiment. The question is simple. Could an egg survive a fall all the way from outer space to the ground here on Earth? This isn't just about gravity. It's about speed, heat, and the incredible journey an object takes when it comes home to our planet. We have to consider so many things. We call our planet Earth our home, and it has a very special blanket of air around it called the atmosphere. This atmosphere protects us from many things from space, but it also creates some serious challenges for anything trying to get through it. Our little egg is about to face the biggest challenge of its life. To figure this out, we need to be scientists. We need to ask questions and break the problem down into smaller pieces. First, where does space even begin? How high up are we talking about? Then what happens to an object when it falls from that incredible height? It's not like dropping it from a tree. The forces involved are massive, truly astronomical. We will explore the science of falling, the intense heat of re-entry, and the amazing speeds our egg would reach. It's a journey that involves some of the most powerful forces in nature, all acting on one small, fragile egg. So, let's put on our thinking caps and get ready for an adventure. This is more than just an egg drop. It's a mission. We're going to explore the edge of our world and the science that governs a fall from the stars. We will look at the problems our egg astronaut, let's call her Eggsplorer, will face on her daring descent. And then, we'll get creative and think like engineers. Could we build something to help her survive? Could we design a vessel that would protect her from the intense heat and the final impact? Let's consider the science. First things first, what do we mean when we say space? It's not like there is a big sign floating up there that says, "Welcome to space." Population zero, mostly. Scientists have an imaginary line called the Kármán line. This line is about 100 kilometers or 62 miles, straight up from the surface of the Earth. If you go above this line, you're generally considered an astronaut. That is way, way higher than airplanes fly. It's so high that the air is incredibly thin, almost a vacuum. From there, the Earth looks like a beautiful blue and white marble. That is where our egg's journey begins. So imagine our brave little egg floating at the Kármán line. If we just let it go, it wouldn't just fall straight down at first. Because the Earth is spinning, our egg would have some sideways motion. It would start to orbit or circle the Earth. To get it to fall, we would have to slow it down so that gravity could pull it in. Once gravity takes over, our egg starts its long descent. At first, the fall would be silent and slow because there's almost no air to push against. The egg would just be pulled by Earth's gravity, getting faster and faster as it gets closer. As the egg falls, its speed increases dramatically. We're not talking about the speed of a car on the highway. We are talking about speeds of thousands of miles per hour. This is called terminal velocity, but up where the air is thin, that terminal or final speed is incredibly high. An object falling from this height can reach speeds of over 17,000 miles per hour. Think about that. That is many, many times faster than a speeding bullet. Our egg is no longer just falling. It is screaming through the upper reaches of the atmosphere at an unbelievable velocity, a tiny projectile on a cosmic scale. This incredible speed is the first major problem for our egg. An object moving that fast has a huge amount of energy. It is what scientists call kinetic energy, the energy of motion. The faster you go, the more kinetic energy you have. All of that energy has to go somewhere when the egg starts to hit the thicker parts of the atmosphere. This is where the real drama begins. The fall through the near vacuum of space is the easy part. The hard part is surviving the welcome party that our atmosphere is about to throw for it. The journey is just getting started, and the most dangerous part is still to come. As our egg plummets towards Earth, it eventually starts to hit more and more air molecules. At first, up high, the air is very thin, but as it gets lower, the atmosphere gets thicker and denser. Imagine running into a swimming pool. The water pushes against you and slows you down, right? The same thing happens to our egg, but instead of water, it's hitting air, and it's doing it at thousands of miles per hour. This creates an incredible amount of friction. The air in front of the egg gets compressed and heats up. It heats up a lot. This isn't just warm, it's thousands of degrees hot. This intense heat is the same thing that space shuttles and meteors experience when they enter the atmosphere. We often see meteors as shooting stars in the night sky. What we're actually seeing is a rock from space burning up because of the intense heat generated by air friction. The rock gets so hot that it glows brightly before it vaporizes into dust. Our poor egg is made of calcium carbonate, egg white, and yolk. It is not made of space rock. It would face the same fate. The shell would instantly incinerate, and the inside would flash boil and turn into vapor. Poof! No more egg. Even if the egg could somehow survive the heat, it would still have to deal with the immense forces of deceleration. Hitting the thick atmosphere at such high speed is like slamming into a wall. The force would be incredible, thousands of times the force of gravity. We call these G-forces. Fighter pilots experience high G-forces, but what our egg would experience would be much, much more. The delicate shell would be crushed instantly by the pressure. It would be like a grape being hit by a sledgehammer. The structure of the egg simply isn't strong enough to handle that kind of stress. So without any protection, our egg has zero chance of survival. Absolutely none. It would be burned to a crisp and crushed by immense forces long before it ever got close to the ground. It wouldn't even make a splat. It would just become a puff of vapor high up in the sky. This shows just how powerful our atmosphere is. It's a protective shield for us on the ground, burning up most of the space debris that comes our way. But for our unprotected egg, the atmosphere is not a soft blanket. It's a wall of fire. To survive, our egg needs some serious help. So the outlook is grim for a naked egg. But what if we think like NASA engineers? We can't just drop the egg. We have to build it a spacecraft. The biggest problem is the heat of re-entry. To solve this, we would need a heat shield. Spacecraft like the Orion capsule have special shields on the bottom made of materials that are designed to burn away. As they burn, they carry the heat away from the spacecraft, protecting the astronauts inside. We could build a small capsule for our egg with a heat shield on the front. This shield would absorb and deflect the fiery heat of the atmosphere. With a heat shield, our egg might survive the burning phase. But what about the speed and the final impact? The capsule would still be falling incredibly fast. We need a way to slow it down. The best way to do that is with a parachute. Once the capsule gets through the hottest part of re-entry and slows down a bit, we could deploy a small drogue parachute to stabilize it. Then, as it gets into the lower, thicker air, we could deploy a much larger main parachute. This parachute would catch the wind and dramatically slow the capsule's descent to a gentle, survivable speed. Inside the capsule, our egg still needs protection. Even with a parachute, the landing might be a little bumpy. We would need to create a soft, cushioned environment for it. We could use foam padding, airbags, or even a gel-like substance to cradle the egg. This would be just like the egg drop experiments at school, but on a much more advanced level. The goal is to absorb the shock of the final landing, ensuring the G-forces on the egg itself are very low. The capsule takes the big hits, while the internal padding provides the final layer of gentle safety for our precious cargo. So, can an egg survive a drop from space? If it's just the egg, the answer is a big, fiery no. But if we use science and engineering to build it its own personal spacecraft, the answer changes. With a proper heat shield to beat the burn, a series of parachutes to slow the fall, and a cushioned interior to soften the landing, our egg just might make it. It shows that with enough ingenuity, we can overcome incredible challenges. The laws of physics are strict, but by understanding them, we can design solutions to survive even the most extreme conditions, from the roof of a school to the edge of space.